Hello students, for class 9, today I am going to continue the first chapter, real numbers of number system. Now today mainly I will discuss on rational number, irrational numbers, and what are their decimal expression, how to write rational and irrational numbers, etc. So rational numbers now for rational numbers, it is of two types. Terminating decimal and non-terminating decimal. Now for non-terminating decimal numbers, they may be of two types. Non-terminating but repeating, and another kind is non-terminating and non-repeating. Now the number which one is non-repeating, this has a special name, which is irrational number. This is irrational number. Clear? Therefore, what we get, that is, we may do the classification like this: real numbers, these are of two types, rational, irrational. Now rational, this is terminating decimal and non-terminating repeating decimal. And irrational number, this is non-terminating, non-repeating decimal. Okay, now for terminating decimal, suppose 2.5, 2.6, 7.779 like this. Non-terminating but repeating. Now what is the meaning of non-terminating? Non-terminating means never terminate. There is division never ends. Like if we are dividing 10 by 3, what will we get? 3, 10, 3 3 are 9, 110 decimal gets 0, 3 3 are 9, again 110 for decimal, 1 more 0, 3. So 3 3 3 3 3 3, this will continue. There is same number is repeating once and again. These are called recurring number. So for this we can write 3.33 dot 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 dot. This is also written as 3.3 recurring or 3.3 bar. We generally use in our book this one. But if this is irrational number, we will say that irrational numbers are non-repeating, non-terminating. Like 2.10, 100, 1000, 1000, and so on. So we cannot say that 10 is repeating. First 10, then 100, then 1000, then 10,000, like that. This is going on. So this is non-terminating and non-repeating. And whenever a number is non-terminating, non-repeating, the number is called what? That is, the number is said irrational number. Clear? The number is said irrational number. Now, how to identify for a rational number whether the number is terminating or non-terminating, repeating? Since the number is a rational number, we can write the number in the form of P by Q. We can write the number in the form of P by Q, where Q not equal to 0. Okay, in the form of P by Q and Q not equal to 0. Now Q, first, number 1 to be noted. P by Q, this fraction must be in list form. List form. Now, if list form the term is not clear, then listen. List form means no more cancelling is possible. Clear? Suppose you are given 6 by 10, but this is not in the list form. It is in 3 by 5. So this is in the list form. Because no more cancelling is possible. Next, what you have to do? Number 2. Find the prime factorization of the denominator Q. Find prime factors of denominator Q. If it is seen that Q is in the form of 2 to the power m into 5 to the power n, means factors either 2 or 5 or both 2 and 5, no other factors except 2 and 5, then the rational number is terminating decimal. Then it is terminating. But if it is seen that the prime factorization of q cannot be written in the form 2 to the power m into 5 to the power n. What does it mean? It means it consists of the factors other than 2 and 5. Then it is non-terminating but repeating. Non-terminating, but repeating. Okay. Now regarding this, I am giving you examples. Say 17 by 512. Clear? 17 by 512. So this is P and this is Q. Now these are in the list form because 512 is not divisible by 17. Okay. Now let us find the prime factors of Q, that is 512. So 512, how to find out? Write this, and in this way first 2, 25 2 ja 50, 6 2 ja 12. Then 2, 12 2 ja 24, 8 2 ja 16. Then 2, 6 2 ja 12, 4 2 ja 8. Then 2, 3 2 ja 6, 2 2 ja 4. Then 2, 16. Then 2, 8. Again 2, 4. Again 2, 2. Again 2, 1. So what you get, that is Q is equal to 512 is equal to 2 to the power 1, 2, 3, 4, 5, 6, 7, 8, 9. 2 to the power 9. That is 2 to the power 9 into 5 to the power 0. There is actually only the factor 2. Now if it is that the denominator consists of the factors 2 only, then what it will be? It is terminating decimal. As Q can be written in the form 2 to the power m into 5 to the power n, hence 17 by 512 will have a terminating decimal. terminating decimal expansion. So the sum ends. Clear? Now I am doing one more sum to show you. Suppose you are given 13 by 680. Now let us find out the prime factors of 680. 2, 340, 2, 170, then 17, 10, then 2, 5. So what we get, that is Q is equal to 680. Here this is P and this is Q in the form of P by Q and Q not equal to 0. So Q is equal to 680, that is equal to 2 to the power 3 into 5 to the power 1 into 17. So what we have seen, besides the factors 2 and 5, it has 17 as its factor. So Q cannot be written in the form 2 to the power m into 5 to the power n, because it has another more factor 17. Therefore 13 by 680 will have a non-terminating but repeating decimal. I think this is clear to you. Next, I am going to show you how to write non-terminating repeating decimal in the form of P by Q. Let us explain this one taking one example. Suppose you are given a question, express .3232 bar in the form P by Q. Let x is equal to 2.32 bar. What does it mean? 2.3232, because it is recurring number. Recurring means reoccurring, that is occurring again and again. That is why this is called recurring number. Now let us multiply this one. Since there are two numbers, two digits under the recurring, under the bar, we need to multiply this 1, then 0, 0. Always 1, then 0 should be the number equal to under the bar. So 1, 0, 0. We need to multiply this equation by 100. So this implies 100x is equal to 232.3232 and so on. That is equal to 232.32 bar. This is equation 1, this is equation 2. Now 2 minus 1 implies 100x minus x is equal to 232.32 bar minus 2.32 bar. That is equal to, now 0.32 bar subtracted, it is 0. 232 minus 2, that is 230. So this implies x is equal to 230 by 99. So what do we get? 230 by 99, it is in the form of P by Q. Obviously P is equal to 230 and Q is equal to 99. Now by inspection only we can write this one. There is one shortcut form I am showing you. 2.32 bar is equal to, what is the technique, how to write? First to write the number without any decimal, without any bar. So what is that? 232 minus the digit which is not within the decimal. What is that? 2 by how many digits are within the bar? 2 digits. So 2 numbers of 9. That is equal to 230 by 99. I am giving you solution of one more sum. Suppose you were given to write 2.322 bar in the form P by Q. How to do that? Let x is equal to 2.322 bar. What does it mean? There is 2.3222 and so on. First we need to bring the decimal. First we need to bring the decimal just before the bar starts, that is here. So decimal to be shifted by 1 digit. So to multiply by 10. This implies 10x is equal to 23.2 bar. That is 23.222 and so on. This is equation 1, this is equation 2. Multiply equation 2 by 10 again, or 1 by 100, and 100x is equal to 232.2 bar. This is equation 3. Now let us subtract, that is, let us perform operate 3 minus 2. What will we get? 100x minus 10x is equal to 232.2 bar minus 23.2 bar. This implies 90x is equal to 2 bar decimal, this is subtracted. So 232 minus 23. So 209. 209. This implies x is equal to 209 by 90. Now let us do in the shortcut form. 2.322 bar is equal to, first to write the number without any decimal, without any bar. So 232 minus, what is the number without bar? 23. by how many digit is under the bar? 1 digit, so 19. How many digit within decimal is without bar? 1, so 1 number 0. That is equal to 209 by 90. Same answer came this time also. Okay. Now let us see